seminar. So welcome to the seminar on digital tools in agriculture. We'll be looking at perceptions of digital tools and barriers to their adoption in agriculture. This is the second seminar in the series. I hope you have enjoyed the first one if you had the chance. Some people are still joining, so unfortunately you'll hear the beeping in the background. Apologies for that. Just a couple of housekeeping announcements at the beginning. So be mindful of the fact that the meeting will be recorded. So do not post anything silly in the chat, please, that you might regret later. We have a fairly strict agenda that Francesca Bellino has kindly organized for us. She is the person in the background. Thank you, Francesca, for organizing the seminar. I'll just do a a quick introduction at the beginning now, and then we'll hear from Evangelia Mourmoura from DG AGRI, who will provide some background statement for us. And then there are three contributions from different projects. The first one will be from Tom Stutton. He'll be talking about ReForest. The second will be from Elias Meriton, and the third contribution will be from Evelyn Rainmoth. I'll introduce them in turn. This is an interactive meeting, so for those of you that were hoping to have a nice nap in the afternoon, this is not the right meeting. What will happen is that as the three presenters talk, they will trigger a question which will turn up on your screen. So keep the window with the Teams open. What you will see is a question appearing, so you answer the question as you see fit. And if you would like to see the statistics appearing as all the other participants take their answers, then keep that little window open. If you do close it and still want to know the result, do not panic, because the outcome will appear in the chat on the side. Okay, so what we'll have, I'll say it again, what we'll have are some questions from the speakers to you, the audience, and as they speak, Francesca will trigger the question which will appear on your Teams window, so do answer the questions, please. There will be a question and answer session at the end for all the talks together. So if you want to ask something, do write it down so you don't forget, and then there will be an opportunity to ask it. Alternatively, if you can't wait, just pop the question into the chat on the side. We can pick them as we go along at the end. Okay, so I think this is all I had to say at the beginning. So I'm just checking my to-say list. Yes, that appears to be it. So at this point, I can hand over to Evangelia, who will be our first contributor this afternoon. Over to you, Evangelia.
Good afternoon, everyone. Thanks, Martin, for giving me the floor. As said, I will try to give you a bit of a framework around digitalization in agriculture, and please give me a few seconds just to share my presentation, and please let me know if you can see it. Is
Yes.
everything okay?
Yes, it shows as a presentation. Thank you. Perfect.
So as Martin said, my name is Evangelia Mourmoura. I work in DG AGRI. I work in the unit of data governance and digitalization in the Directorate for Strategy and Policy Analysis. And I'm leading the team specifically on digitalization policies and strategies for agriculture and rural areas. So first, allow me to start by thanking, of course, the organizers for bringing us together today to discuss on the topic of digital technologies in agriculture and its future. Since, of course, digitalization, you know, also it's not only about technology, it's really about how it can help us to create a sector, a farming sector that is more resilient, competitive, and of course, future-proof. Allow me to start with a short introduction around the vision that was, as you know, recently adopted, because the vision for agriculture and food states very well that farming is not just an industry for Europe. As President von der Leyen emphasized, actually it is strategic and requires bold action from our side. So the vision sets the path for 2040. And we need actually to take bold action. We do not need to stay reactive on the changes that are coming, but we need to adopt a more proactive approach. I will not enter into the details. I think you had also during the previous webinar, my colleague Miguel Fernandez that described more on the vision. Just as a reminder, you know that there are, of course, 4 priorities that were set in the vision: building an attractive sector, strengthening competitiveness and resilience, building a future-proofing agriculture, and valuing food and fostering vibrant rural areas. These are the 4 key priorities that are set in the vision, and what it is really important is that, of course, to succeed in these areas, we need the right enablers in place. So together with research and knowledge, we need also to leverage the potential of digitalization in agriculture. So digitalization is not instrumental only to strengthen the economic performance and the resilience of the sector, but it can also contribute significantly to several sustainability-related policy objectives, as we already know, and as we also currently have under the Common Agricultural Policy. However, there are several issues that are limiting the digital transition, such as perceived high costs, lack of digital skills, trust, or even lack of appropriate connectivity in rural areas or at field level. And this, of course, all these barriers have as a consequence the low adoption of digital tools, which lags behind in agriculture compared also to the other sectors. And we need to approach it in a more strategic way. For that, one key action that was also included in the vision is the launch of an EU digital strategy for agriculture that is set to be delivered by end of 2025. Why, of course, it is important to have such a strategic action. We are all aware, of course, that digitalization benefits several actors in the agri-food system. It can empower farmers, it can provide data-driven insights so that they can also optimize resources, but it can also enhance the resilience of agriculture against external shocks. And of course, since we're talking also for artificial intelligence and digital technologies more and more, we need to also have a specific approach in respect to data availability in order to develop the AI technologies that are needed for the sector. And indeed, what we need to see actually for the future is that we are entering a new world. So digital tools and AI are changing how we live, how we work, how we farm. I think we have all seen and we were impacted actually from this invasion of digital tools and AI in our daily work. And just this illustration just to show you that, of course, digital tools are everywhere, from soil to supermarket, from farm to public services. So digital is everywhere and is part of everything. It's not one only aspect of a specific sector. As said before, of course, despite this progress, the digital adoption rates remain rather low. And maybe also this is also a reason why we do not see so much of how digital can benefit in the end agriculture because of this low uptake. And for this presentation, I would like to present to you some results, some insights from 2 surveys that are done by the European Commission. And that give us also some more elements on what we need to look at where this adoption lies. First, allow me to introduce a simplification survey that you maybe know already. So the simplification survey was an online survey that was addressed to farmers in 2024. It was really for input on simplification of the CAP rules, but of course included also digital aspects. In this survey, we had around 27,000 replies, farmers and other beneficiaries that replied on how procedures and rules that are linked to financial support under the CAP can be simplified. So we wanted to see where the burden lies and to identify with the survey what are the sources of concern and complexity. So I will like to give you some insights on that, but please be aware that this survey and the results that I will show you, it's really, it's not a stratified study. However, these results will feed into a specific study that it is performed already on simplification and administrative burden for farmers under the CAP that will be delivered and published soon. And it is performed by the EU CAP network. So I think it is also very relevant to digitalization because there are several digital aspects that will be studied in during that survey. So 2 points that are were extremely useful for us and interesting for us is from our internal analysis to understand age-related concerns in respect to digital adoption. So as you can see here in the first chart, you can see the share of respondents to the survey that expressed difficulties in respect to the use of digital and technology per age group. And of course, just to say here that it is not the use of tools on the field, it's mainly the use of digital tools and technology in respect to the public services. But this is also a very good insight that we have. So as you can see, we have 26% of the respondents that were between 40 and 49 declaring that they had really difficulties with digital and tech, but also 41% from 50 to 64 years old, 41% of these farmers that said that they actually have difficulties with digitalization and technologies. And on the other chart, you can see the relation in respect to the farm size. So how many respondents expressed difficulties related to digital and technology per farm size. And here you can see that the major percentage, the main percentage, the 43% of the respondents belong to the category of farm sizes between 5 and 50 hectares. The more we increase the farm size, the less we see that there are issues. But of course, we have also the other side that for small farmers, less than 5 hectares, they also seem not to have such a big issue. Of course, we do not know if, for example, that this part, the green part of this chart, is because they do not use so much this kind of tools or for any other reason. As I said, this simplification survey did not really go into depth, but it will be studied in the relevant study from the EU CAP network. So this is the first insight that, of course, there is an age related aspect and the farm size aspect in respect to the adoption of digital tools. And then I would like to show to you this result in respect to the recording of data, which also gave us insights in respect to how farmers use, at which degree they use automatic tools to record the data. So this diagram presents the recording of data in respect to manual recording, for example, if it was paper-based or even spreadsheets, whether farmers use management softwares like farm management information systems, or even whether there is a really automatic recording by sensors and connected machineries, which records directly the data in a software. So as you can see here with orange category, you can see that most of the farmers use still manual recording of data. So it's more than 20% of all the farmers for all categories. Either we talk about data on animal identification and movement, whether we talk about use of pesticides, fertilizers, or water use, most of the farmers use still manual recording. We have some farmers using management software tools, but most of them are around 20% of the farmers that replied that they use this kind of systems. And when it comes to automatic recording, then as you can see, the categories is almost close to zero. So this shows that, of course, still the data collection methods, and farmers are requested to collect a lot of data, are mainly manual based. So these are the first insights from the simplification survey, but I would like also to present to you some preliminary results also that we have from a JRC study that was performed last year. It's a survey-based study from the Joint Research Center to study the adoption of digital tools at EU level. So this study included 9 countries: France, Germany, Hungary, Ireland, Italy, Poland, Spain, Greece, and Lithuania. So JRC tried to cover the different regions of Europe, north, south, east, west, including different regions per country, so that the sample is as much as possible representative to the EU. And of course, they tried also to cover different farming specializations from crop, livestock, and mixed, and also different farm sizes, small, medium, and large. The farmers that were interviewed, the number was 1,440 farmers around EU, and the results from the JRC study were weighted to represent the farm population, because from DG Agri side, when we requested this study, we wanted really to understand what is the baseline of the adoption of digital tools at EU level, since we're lagging certain results on this aspect. So I would like also here to say that these are preliminary results that were also presented from the JRC during the AgriDigital conference that took place in December. And currently JRC is performing several analyses, and the report is expected hopefully by summer to be published by the JRC. So some insights. First of all, JRC studied where we are with the adoption of digital technologies. Here you can see a chart on crop farmers, what crop farmers replied, where they are with the adoption of digital tools. As you can see, I hope that you can see it well, 58% of the farmers said that already currently they have adopted tools such as digital field records. And they use also maps from satellite data. However, when we go towards more heavy machinery with digital aspects like tractors with GPS systems, we can see that we fall to 34% of adoption at EU level. And of course, then the more we see more specific technologies, the less the uptake of digital technologies increases. Of course, when we see here, for example, augmented reality technologies, we see really very low uptake. But of course, these are very specific technologies, and one can say that farmers do not either are not aware of these technologies, or maybe they are not profitable enough to be adopted. So what we can in any case see is that even if we think only about the digital field records, there is still a lot to progress on this category, because we have 14% of farmers that said that they plan to adopt in the next 5 years, but the rest, they did not declare anything like that. So there is still a lot of progress if we consider that in 5 years we will be already in 2030, and as we said, the pace of technologies is being developed very quickly, so we might need to focus more on this adoption of digital technologies. When it comes to livestock, we have similar results, meaning that, of course, most of the farmers adopt digital livestock records. But when we go once again to more heavy machinery connected with digital aspects, we see a lower adoption rate, like the automatic milking systems were around 14%, collars and robotic feed pushers, it's still below 10%, and we see a similar image for the prospect for the future. So the uptake is still low, it is happening, but it is low. And now when we come once again to the data side of the digital tools, data collection and sharing of data, JRC also tried to look at what is happening at on that side. So JRC also confirms what we saw with the simplification survey, that more than 50% of the farmers collect data mostly on paper basis. And when we talk about digital, let's say recording, this means spreadsheets or scanned documents, so not real digital software with automatic recording and connection of systems. When it comes to sharing of data, farmers were also asked whether they share data and with whom. So most of the farmers, they said that they do not share this data. If they do share it with advisors or other farmers. But as we see that with public administrations, companies, or even with research institutes, they do not share so much data on their agricultural activities. Finally, in respect to barriers and drivers, a few insights of what was collected. So the main barrier for most of the farmers was the high cost of digital technologies, followed by the lack of knowledge on what is available on the market, and of course the lack of government support. What it is also very interesting to see is that many farmers, like 14%, they question actually the profitability of digital technology, so they do not see how they would benefit from that. And what it is also, I think, a challenge still, even though we consider that it is something that most of the rural areas have solved, is the lack of internet connectivity. And of course, if there is a gap, then any adoption of digital tools also on the field cannot take place if there is no internet connectivity. In respect to drivers, of course, there are several drivers that were asked, that farmers were asked their opinion on. What was interesting for us when we first saw it is that the driver for digital adoption, the main one, was meeting regulatory or legislative requirements. So for them, it seems that their perception is that digital tools can help them really to meet legal requirements. And following that, we have as a second main driver, reducing operational costs. So optimizing input and time, and of course costs on their agricultural activities. So there are several drivers afterwards in respect to business opportunities or improving well-being. But what it will be also very interesting to see is that if a digital technology is suggested or recommended by farm advisors, you can see that it is at the level of 3%. So this is a bit of how to say, a contradiction from what we also see from projects, from discussions that we have. So hopefully we'll have more insights when the JRC really concludes on the analysis and on the different aspects. But I think the report would worth studying it a bit more in details to understand where we need to act. So having in mind also the time, I will not go into further details. It was just to give you a flavor of what we are having right now at DG AGRI to analyze. But what we see is that digitalization is not really one simple aspect. When we talk about boosting digitalization for competitiveness, sustainability, for a future-oriented sector, we look actually at the enabling environments that will help us to foster this digitalization. So three are the key enablers on that: infrastructure in terms of connectivity, equipment, meaning the right digital tools, the right platforms, softwares that the farmers can use, but of course registries, because we need to think also that the farmer is always, let's say, accompanied by public services or other advisors. So we need to think of how all these systems communicate between each other to facilitate also the life of the farmer. The second enabler, which is very important, is capacity building. So we need to invest on training, skills, and the correct advisory environment. And of course, the main enabler is the appropriate financial support, meaning having adequate funding mechanism to foster the boost of the digital uptake. Just to mention here that, of course, we do not start from scratch. The current Common Agricultural Policy focuses a lot on digitalization. First of all, under the CAP, currently digitalization has been recognized as a cross-cutting objective to achieve the specific objectives of the CAP. And for the first time, member states have submitted digital strategies in their CAP plans describing how they will advance digitalization in agriculture, rural areas, and administrations. And for that, they have a toolbox in their hands. They can use investments, eco schemes, agro-environmental commitments, and other types of interventions, depending on their needs, in order to boost the digital uptake. So all of this, of course, need to be taken up for the development of the EU digital strategy that will be there by end of 2025. And we need really to build on what is already in place. So just to wrap up with some concluding thoughts and for the rest of the discussion, some key takeaways. Digital adoption is underway, but of course not everyone is moving at the same pace. We need to bring all actors, farmers, advisors, administrations to the same level of digital readiness. Barriers are still very real. We have high costs. We have also complex and fragmented tools. There is still poor connectivity on certain areas, and of course, skill gaps. And these issues cannot be ignored. So we need really to act on them. At the same time, we see already there are some clear drivers, from regulatory incentives to really operational benefits like input optimization and market opportunities. And these show us where also to focus a bit our efforts. And most importantly, no single actor for me can solve this alone. So real progress will come from really real and strong collaboration across tech providers, policymakers, and the farming community. So there is no single silver bullet. So in order to unlock the full potential of digital agriculture, we need to be strategic and to have a coordinated effort. So I will stop here, and I would like to thank you for your attention.
Thank you, Evangelia. This was rather insightful. I have taken some screenshots to use later in lectures. I hope that's okay, especially of the survey results. I can see a lot of clapping hands coming up at the bottom, which is great. So we get engagement. of the audience. And moving swiftly on, we go to the second speaker, which is Tom Staton, who will be talking about the ReForest project. So Tom, if you are ready, you can share your screen. In the meantime, I will just remind all of you, we'll be asking questions as we go. And if you have some questions of your own, keep them for later or pop them into the chat. I'll pick them for the question and answer session at the end. So over to you, Tom.
Thank you, Martin. I assume you can see my slides in presentation mode. Great. I'm Tom. I'm based at the University of Reading, and today I will be talking about some practical applications of digital tools for agroforestry systems, and talking about some of our experiences from the ReForest project, which Martin is coordinating. And I should say I'm presenting this, but a lot of the content has been provided by the Organic Research Centre and by FarmTree, who are partners in the project. So thank you to them. And today I will be talking about these 5 different sections in this 20-minute slot. So firstly, I will introduce agroforestry and the ReForest project very briefly. I'll talk a little bit about the living lab approach in ReForest. And then I'll talk about 2 digital tools that we've been using in the project. So firstly, the public goods tool, which aims to assess farm level sustainability of agroforestry farms. And then secondly, the FarmTree tool, which aims to project the performance of agroforestry systems. And I'll finish with some questions for you, actually. So particularly around the use of digital tools for agroforestry systems and how useful you think they would be at different stages of agroforestry system design and implementation. So I'm sure a lot of you are already familiar with agroforestry, but just to briefly recap, essentially we're talking about farming with trees, but the trees are a productive part of the system, really. So I quite like this definition, which emphasizes that the trees are deliberately integrated into crop and/or animal livestock systems, and benefiting from the ecological and economic interactions between the trees and the crops and/or livestock. And we can kind of summarize this using the 4 I's of agroforestry. So intentional, the trees or shrubs are intentionally part of the system. They're integrated into the system, so often into the field itself, or potentially into landscapes. Intensive, so the trees should be a productive part of the system. And interactions, so we're trying to maximize these beneficial interactions between trees and the crops and livestock in these systems. And in the ReForest project, we are studying these agroforestry systems across Europe. So this is about agroforestry at the forefront of farming sustainability in multifunctional landscapes in Europe. We're made up of 14 partners across 10 countries, and these are our objectives. So to enhance the understanding of agroforestry systems, to enable local innovation and support mechanisms, to characterize and quantify the performance of existing agroforestry, developing monitoring and verification capability, developing financial models, and finally aiming to have policy impact. And we're focusing on food production and tree production as well, carbon capture and biodiversity. And you can see there's lots of opportunities to use digital tools within these objectives. So for example, quantifying the performance, which we'll look at with the public goods tool in a moment. And living labs are a key component of the ReForest project. Again, I'm sure many of you are familiar with the living labs concept, but just to recap, these are initiatives in which experimentation is conducted on real farms, and we're working with farmers and other actors from the beginning as equal partners to propose ideas, test them, improve them, and promoting them further. And in the digital tools I'll be talking about in a moment, we've been using these and applying these and developing these in coordination with our living labs. And our living lab approach aims to follow this CRAMS criteria, so co-creating solutions, testing and experimenting in real-life conditions, active involvement of end users, using multiple methods, and participation of stakeholders. And we have 8 living labs in the ReForest project, as you can see here on the map. And there's a diversity of different agroforestry systems. So agroforestry can involve intercropping trees and arable crops or vegetables, but it can also integrate livestock. So systems like wood pastures are included within that. And using some different approaches. So some adopt a kind of hub and spoke model centered around a particular demonstration farm. Others are more a loose network of stakeholders practicing agroforestry. And we're aiming to inform and test tools for decision support. Okay, so I will now talk about the first of the 2 digital tools I'll be talking about today. And this is called the Public Goods tool, which we've been using to assess farm-level sustainability of agroforestry farms. And the Public Goods tool was originally developed quite some years ago, back in 2011, 2012, originally developed to assess the provision of public goods on farms. Since then, the tool has been adapted for lots of different purposes. And this is just a very simplified timeline of adaptation for agroforestry systems. Most recently, under this ReForest project, we've adapted the tool for agroforestry systems. But there are lots of other versions of the tool available, so it is very adaptable. And data collection in the public goods tool, so this is based on an Excel spreadsheet. It involves a researcher visiting the farmer to collect the data. In this version of the tool anyway. There are some other versions which are online and farmers can do themselves. It is quite data intensive, which is one of the limitations of the tool. So it typically takes around between 2 and 4 hours, which is quite a big demand on the farmer's time. And we look at these 9 different areas of sustainability and public goods. This is just one example of what the tool looks like in terms of the input data. So here we're looking at a sheet on soil management. So we ask the farmer questions like, how often do they do soil analysis, if ever? If they're increasing, decreasing, or maintaining soil organic matter, and some questions around soil management, winter grazing, and erosion. And these are all self-reported values. So that's another caveat of the tool to be aware of, is that we're relying on the farmer giving us honest answers. So there isn't any field data or empirical data that goes into this tool. So the outputs of the tool can be useful for research, and there have been many scientific papers published using other versions of the public goods tool. This is the preliminary data that we've collected within the ReForest project from agroforestry farms. And we can see here that, so I should explain what this means. So here we're looking at scores between 0 and 5 for each of these categories of public goods, with 5 being the top score. So that's where a farm is performing really well, and 0 being the lowest score. And these are kind of benchmarked against standard values. And the blue line here is the average, the mean average across our 12 farms, agroforestry farms so far, with the red being the highest scoring farm and the black being the lowest scoring farm. And just from this preliminary data, we can see that these 4 categories are performing consistently highly. So even the minimum scores are quite high. So these are soil management, animal welfare, business resilience, and social capital. Which is supported by existing literature on agroforestry systems, particularly the soil management. So we know already that agroforestry systems tend to be very good for soil protection and soil health. but also shedding light on other things which we often, I think, don't think about in terms of the benefits of agroforestry, like the social capital, I think is often overlooked. And we can see these other three categories are much more variable, so that gives us opportunity to explore why that might be. And as well as being useful for researchers, this can also be useful for farmers to understand how their farm is performing and how it could be improved in terms of its sustainability. So this is just one example I picked for an agroforestry farm. This is how they scored for each of the categories. And I think farmers are kind of naturally drawn to the lowest scoring ones. And okay, why did I only score 2.3 for agricultural systems diversity? And in this case, we can go into the data and look why it didn't score particularly highly. So on this farm, they only had one livestock species. They only had one marketing outlet, and they didn't have any on-farm processing. So those are the main factors that limited the score for that category. And of course, this is just a tool. It may be that it's not feasible for the farm to do anything about these things. So it's not an absolute score, but it helps the farmer to think about how they could potentially improve their sustainability. I've just picked out another example here, which was the second lowest, although it's still a pretty good score of 3.5. And in this case, that was limited by their employment levels, by the lack of any external businesses or enterprise stacking, and the quite high staff workload. So again, that might give the farmer something to think about in terms of how they could address that by perhaps using interns or a local volunteer network, if that's feasible within their farm context, which it may not be. And it may be that a score of 3.5 is all that they can feasibly achieve in their context. Just to briefly mention a couple of other sustainability assessments, which are available online. So the ReLivestock tool is one version, another version of the public goods tool that's been rebadged, and that's particularly tailored towards livestock systems, as the name would suggest. And that's available online, so do go and have a look at that if you're interested. And in the UK, we've developed this global farm metric recently, again under a separate project, which does involve some field data, I think, and that aims to be a farmer-friendly sustainability assessment. So do have a look at that if you're interested. Okay, so moving on to another tool that we've been using in the ReForest project. This is called Farm Tree, and this aims to quantify and project agroforestry system performance. So this is really a planning tool at the planning stage, aiming to project the effects of agroforestry on carbon sequestration and on finances and the environment. And this flowchart at the bottom here demonstrates the problem that Farm Tree tries to resolve. So if we're thinking about planting trees on a farm, if we want to project the potential impact of that, we need to do a lot of complex data collection, and we'll probably have incomplete data, which is a barrier to investing in those trees and therefore implementation of agroforestry. So Farm Tree aims to simplify this process by requiring only simple data inputs, and then using a combination of open source data as well as the Farm Tree database, which contains lots of data on tree crop interactions, and then providing a holistic output to farmers and decision makers about how their agroforestry system might perform. And the tool was originally developed in Africa and has been expanded to Europe under the ReForest project. And this is some example outputs from the tool. This is actually from a tropical, I think, African agroforestry system. But you can see that the tool gives us lots of different data outputs. So here we're looking at the graphs are very small. but you can see that we're looking at time over a 40-year period here. And this is projecting vegetation cover, carbon stocks, and nutrient stocks, yields, cash flow, and water flows. This is an example of the input of Farm Tree. So this is a web-based tool. It is a paid-for system, so you do have to sign up and pay for it. But there is a free demo version available. And essentially draw your farm on the map, and that then provides some open source data about the soil type. And then you enter details of your planned agroforestry system. And a lot of the values here are default built-in values. So you don't necessarily have to collect a lot of data, but they can be adjusted if you want to give you more precise projections.
Hi, Tom, sorry for jumping in. You have a
Yeah,
couple
sure.
of minutes left.
Yep, that's fine. Just finishing up, I think. So this is an example from one of the living lab farms in the UK, where we've applied the Farm Tree, and we've been working with them, or the Organic Research Centre has been working with them to develop this. So here we're looking at a seasonal cover of different crops over time. And you can see here in the tabs above that it provides lots of different projections in terms of yields and environmental factors, as well as some social factors like labour requirements. So again, this is just a tool. Obviously, it's based on a lot of assumptions about how the trees and the crops will interact, but it helps the farmer to understand some of the key constraints they might want to think about when they're designing their system. And that's it for my part. I think we have a series of questions now, if we can bring them up. Maybe I will stop sharing. Yes, great. So our poll is up. So we have a few questions here. The first one is nice and easy, which is, who are you? So please fill that in and press submit. I think if you try not to press the X button in the top right, otherwise it will disappear. We have 28 responses, so please do fill that out before we move on. So most of us are researchers. I'm interested to know what all the other people are. Okay, shall we move on? So another nice easy one, which is, what country are you based in? So this is just typing in the box and pressing submit. And as I think I can't see this, mine isn't updating, but I guess people have done that. So perhaps if we can move on. Okay, so now on to some more interesting questions. So I have a series of 4 questions for you here. And what we're going to do is go through a hypothetical journey where we're designing and implementing an agroforestry system and thinking about the advice and the tools that we might use for that. So in this first part, we're thinking about how agroforestry. So imagine you have a farm, and think about and you're thinking about implementing agroforestry into that farm and how it might fit into your whole farm approach. And I've listed 5 different sources of information or advice here. And if you could rank them by which you think would be the most useful. And this is just thinking about how agroforestry would fit into your farm, not thinking about the specifics of design just a very high level holistic stage. So here the top one should be the most useful, the bottom one should be the least useful, and you can just drag and drop the options. We'll just give you a few more seconds to do that. I've got quite a few responses. That's great. So just give you a few seconds to think about that. And perhaps we should move on now to the next part. Great. So we've got exactly the same options here, but now we've imagined, well, we've worked out how agroforestry will fit into our farm, but now we want to design the specifics of the farm. So now we're thinking about what species to plant, what kind of density, what spacing, how to protect the trees, all the nitty-gritty design parts. So again, if you can rank how useful these sources of advice and tools would be, and press submit when you're ready. Just give you a few more seconds. And perhaps if we move on now to the third part. Okay, so now we've planted our agroforestry system. Oh no, so we are about to plant it, and we're now thinking about the practicalities of establishing and managing the system. So when we're going to plant them, how we're going to manage the trees, aftercare of the trees, and that kind of thing. So again, if you rank these sources of advice again and press submit when you're ready. Good, lots of responses. I'll just give you a few more seconds and we'll go on to the final question. Okay, let's move on. Final question now. We've planted and set up our agroforestry system, and now we want to monitor how it's performing holistically. So the financial performance, environmental performance, and everything. So again, rank how useful these would be. Okay, just a few more seconds to finish that off, and then that's me done for now. Okay, I think we can close it there. So thanks very much, and happy to take questions later.
Okay, thank you, Tom. It was interesting to see the bars moving as people were responding to the questions. So we move on to our third speaker now. This is Elias Moitan from Harper Adams University. So over to you, Elias. I can see that you're ready.
Yeah, thank you, Martin, for giving me the floor. Let me first check quickly the slides are working properly. Can you see them fine in presenting mode?
Yeah, this is good.
Great. So my name is Elias Maritan. As Martin said, I'm a research associate at Harper Adams University, and I started to work with the university at the onset of Digitalisation for Agroecology project. And what I've been doing for the first part of the project, we developed a model, a linear programming model that is capable of assessing the economic, environmental, and social implications of technology adoption at the farm level. This model is based on a mathematical approach. It takes a range of equations that are used to simulate the specific goals under investigation. And then once the model is run, you obtain an output, which is an optimized farm plan based on the available resources. And the goal is to meet all the goals considered as closely as possible. And what we do, we run the model for innovative technology, we run the model for conventional technology, and then based on the outputs, we compare the optimal plans. And in that way, we're able to identify barriers, drivers, as well as potential trade-offs among different dimensions of agroecology. My presentation today is focused on 4 specific case studies. The first one is based in Bavaria, in Germany, and we looked at the Farm Droid FD20 seeding and weeding robot. It's a solar-powered robot that does autonomous seeding and autonomous mechanical weeding, and has also recently been commercialized with an option to conduct spot spraying with herbicides in unconventional farms. The second case study is based in the UK. This is based on the experience we had at Harper Adams University with retrofitted equipment. We have been using this equipment for strip intercropping, which is a sort of diversification of crops in the field. The crops are arranged in 2-meter strips, and this small-scale equipment travels autonomously up and down to conduct the whole range of field operations. The third case study is drone pesticide spraying. This is based in Greece, in viticulture. And this case study was selected because it was really interesting to see at the effect of regulation. Currently, drone spraying in Europe is banned, and there are some exceptional permissions that can be obtained. So we looked at those scenarios where derogation could be obtained and how those compare to conventional pesticide spraying. And finally, the 4 case study is based on the virtual fencing technology, which is used to manage grazing animals on pasture based on invisible boundaries that are managed with an app. And this study is also based in the UK. Now I'm going through the results for each of the 4 case studies. So the first one is the robotic weeding in Bavaria, Germany. So basically, when you see a green number, that means that the new technology is providing a positive outcome, whereas if the figure in the percentage is red, it means the outcome is negative. And we are looking at a conventional farm as well as an organic farm. And the most interesting difference here is that compared to conventional herbicide spraying, there are some variable cost savings in terms of fuel consumption and obviously herbicide input reduction. But when you take into account as fixed cost, the cost to buy the technology, then the return is completely eroded and the farm actually makes a negative return. This does not happen on the organic farm. On the organic farm, we have savings in fuel and manual weeding labor, and the organic farm is also able to absorb the additional cost of the technology. In both cases, we have a bit of increase in the sugar beet production costs. So these are the farm was focused on producing sugar beet because this technology is developed for that specific crop. And in this measure, we also included the family labor input, which is unpaid in the farm budget. But in this case, we wanted to see what is the effect of increased labor input if this was paid. And what we see is that the production costs are increased by a small percentage, and also below the family labor productivity indicator, which is a social goal, is drastically reduced. Which means that the farmer saves on temporary labor, but at the same time, his time is switched to more skilled tasks, and the total labor input is much higher for family labor at this point after adopting this technology. And finally, we also measured the sugar beet carbon footprint as an ecological goal, and we found a bit of a difference here, a bit of advantage in terms of environmental impact, but this was not substantial. And then, based on all these results together, we produced what we call preferences of farmers. We look at 3 different farmer profiles, which are characterized by a different level of importance on the specific goals. So we have a production-oriented farmer, which is only concerned with the economic returns. And we can see that in both cases, the new technology is preferred, though by not a great extent on the conventional farm. There's only a 2% preference difference. The ecologically oriented farmer is assumed to place an importance of 70% on the economic goal and 30% on the environmental goal. And here again, we have a preference for the new technology because of the improved economical performance, as well as a bit of decrease in the carbon footprint of crop produced. But then, if you look at the socially oriented farmer, which is a farmer that also places importance on labor productivity, in the sense that the higher the productivity is for the family labor, the more time there is for other life activities. So it's a measure of work-life balance. In this case, the preference switches away from the farm droid FD20 because of the much greater labor input required from his side once the technology is adopted. Yeah. So now moving to the second case study, this is the autonomous strip intercropping case study based in the UK. In this case, so first of all, the technology that we use at Harper Adams University is based on a small-sized tractor and a small-sized combine harvester, which is retrofitted with an autonomous retrofit kit and a GPS receiver. And this is costed at about £20,000. So it's a relatively cheap technology because the farmer does not need to buy a new piece of equipment. It can just convert the existing equipment to autonomous mode. And in this case, we looked at a comparison on a conventional farm between autonomous strip intercropping, whole field monocropping, which is the common monoculture using large-scale equipment. And also we looked at what happens if strip intercropping is managed with human-driven equipment. And one of the main barriers of strip intercropping is the increase in labor inputs. And what we see here, all the numbers are in favor of strong autonomous strip intercropping when this is compared to whole field monocropping. And we also have some economic advantages compared to non-robotic strip intercropping. And here the advantages are mostly because of technology cost savings. This technology is not really expensive, so we see the positive results in the economic indicators. And also we have some labor input reduction, as well as some environmental benefits compared to whole field monocropping. We have a greater agricultural biodiversity, which is measured using an indicator by the FAO. And then we have a 44% lower soil compaction compared to whole field monocropping, which is mostly due to the smaller size of the equipment, and therefore the equipment is lighter and doesn't cause as much compaction. Sorry. And here, again, we combined all the goals together, and we find that the preference is always for the autonomous strip intercropping equipment, regardless of the baseline comparison. And a note must be made here. This technology is assumed to be highly reliable. It's basically just common equipment, common tractor implements that are able to travel the field at quite fast speeds. These figures will definitely change if we looked at, for example, self-propelled robots that are less reliable and also face challenges when being transported on public roads due to regulation. Now moving to the third case study. This is the drone pesticide spraying study based in Greece. In this case, we looked at conventional viticulture and we compared a highly mechanized vineyard, so based on a flat terrain. And also we had a comparison between drones and backpack spraying on a low mechanization vineyard, which is located in a steep slope area. And on the left side, we have the comparison between drone spraying and conventional vine spraying. And in this analysis, we assumed that the technology will be hired because the regulation is so difficult that it's not feasible at the moment for farmers to own the technology. And this is what we have seen, for example, in Germany. Most of the farmers are hiring this technology rather than owning it. And the fees are assumed to be 50% of what is currently charged in Germany. And these fees are much higher, for example, than what is currently paid in Australia and the US, where this practice is really common. And as we can see here, the economic results are against the drone spraying technology. The fees are negating all the savings that are achieved after adopting it. Environmental pollution was measured using an indicator that is used by the Danish government to quantify pesticide tax. And because it is not yet possible to reduce the amount of pesticide used, even if this is sprayed with the drones, the environmental pollution outcome is identical across the comparisons. But then we have a benefit in terms of human exposure to pesticides. This is 50% lower on the flat vineyard and 67% lower on the steep slope vineyard. And this is in line with studies that are demonstrating that when you use spray drones, the human workers are less exposed to harmful substances. And here again, we are combining all the goals achievements, and the preferences are identical for all the decision maker types, regardless of the type of the vineyard considered. What happens here is that if farmers are giving importance to production indicators or ecological indicators, they prefer to stick to a conventional vine sprayer or backpack spraying. But then when the importance is given to the social goal, which is the human exposure to pesticide goal, in that case, the decision switches away and drones are preferred. So there is a trade-off between human exposure to pesticides and on the other hand, with the economic performance of the vineyards. And finally, my last case study is the virtual fencing case study on cattle grazing farms. In this case, we looked at two different farm types. The first one is an intensive grazing farm in the UK lowlands. And the second one is an extensive grazing farm in the UK uplands. And the reason why we looked at an upland farm is because in this type of areas in the UK, it is not allowed to install physical fences. So we imagined that the virtual fencing technology could have an interesting niche market. On the left-hand side, for the intensive grazing farm, we compared the use of virtual fencing with two scenarios. One was a set stocking scenario, so continuous grazing of the same area. Then we also looked at a comparison between rotational stocking managed with electric fencing and rotational grazing managed with virtual fencing. And what we see in this case is that, again, like in the FarmDroid FD20 study, the cost of the technology, so the return over fixed costs, negates most of the savings that can be achieved, for example, through a reduced input of labor. In this case, also we have an issue with how the greenhouse gas emission indicator is expressed. You can see that if we count the total farm emissions, then the virtual fencing technology will generate a 2% higher amount of greenhouse gases, while if you look at the beef carbon footprint, because rotational stocking is more productive, then the ecological indicator will be in favor of the virtual fencing technology. So the outcome really depends on how this is expressed. If you look at the extensive grazing farm instead, the cost of the technology negates all the benefits. There is a reduction of return over fixed costs by 70% when adopting this technology. In this case, we do not have a difference in total greenhouse gas emissions because the farm was assumed to protect 10% of the area and receive government payments for biodiversity conservation. And again here, the indicator on greenhouse gas emissions is rewarding extensification of farming if expressed in absolute values. When you express it in carbon emission intensity, then sustainable intensification is rewarded. So the -2% is seen there for the virtual fencing technology. And now moving to the end, again, here we are combining all the goals, so the ecological and the economic goals considered in this analysis. And on the intensive grazing farm, the preferences are for electric fencing because of a much cheaper ownership cost. And on the extensive grazing farm, we have a preference for set stocking, so continuous stocking of the area without ensuring any biodiversity conservation. And this is because of the poor economic performance when you account for the cost of the technology. In this slide here, I put all the drivers and barriers together that arose from the 4 case studies. We have recently prepared a report that will be published within the end of this month, and so you can find more details about each driver and barrier here. At this stage, I just want to show that labor input can be a driver or a barrier depending on the technology under consideration. And also we have a tendency for barriers to be of economic nature, while drivers are mixed. An important barrier is a lack of relevant data and indicators. It's often very difficult to find reliable indicators for environmental measures. And as far as social goals are concerned, the difficulty is that these are often qualitative, so they're really hard to quantify. And finally, here are my main conclusions. The economic, environmental, and social outcomes of digitalization adoption have substantial differences among production systems, farm types, and technologies. Some of the key aspects to consider when adopting technologies are the barriers related to the high technology cost, which was also shown in one of the previous presentations today, and also the degree of technology specialization. So how many field operations can actually be accomplished with that technology, and this has a negative impact on the cost of adoption. Also, an important aspect is reliability and the operational speed, which if is too slow, then it will eventually increase the labor input rather than reducing it. Then we also have an important barrier when it comes to regulation. For example, the banning of spray drones in Europe, or the difficulty to travel autonomously on public roads. And that's a logistical challenge, especially for farms that are characterized by a large number of small fields. And finally, the environmental impact and the impact on human health are generally in favor of innovative technology. But even when these are achieved, especially in the environmental impact case, they're not really substantial. And most importantly, this is really dependent on how these are expressed, as we have seen in the virtual fencing study. And this is it from my side. Thank you for your attention. And I think now we have a question for the audience. Yeah, so I just have a quick question here about, as we've seen in my modeling, we tried to give a score to the importance of the economic, environmental, and social indicators. So I wanted to ask the audience, how would you rank these three? According to you, how important are they from the farmers? Will the farmer give priority to improve the economic performance, a lower environmental impact, or enhanced human health and safety? So we have 12 responses, I think. we could give it one more minute. Yeah, so I think we can pick up the answer later, but for now I can see that environmental impact is ranking as last, and the first one is improved economic performance, which is also what the recent literature is showing, that before looking at other functions of agriculture, it's really important that the farm is able to survive. So I think I agree with the opinion of the audience. And yeah, I guess that's it for me now, Martin.
Okay, Elias, thank you. Thank you for an insightful talk. So we go to our last speaker, who is Evelyn Reinmuth from Hohenheim University.
That should be visible now. All good?
Yep,
Yeah.
I can see the presentation and hear you, so you're good to go.
Thank you. So welcome also on behalf of the Path2Dea project. We would like to give you an insight into the results of our stakeholder engagement in analyzing how to overcome barriers that hinder the uptake of digital tools in agroecological farming systems. I apologize, I'm with the flu, so if I have a little bit problems with breathing, this is due to that fact, but we'll manage. So anyways, let's dig into what we found. So despite the vast area of tools and technologies available for agriculture, agroecological farmers are reluctant to engage in digital agriculture and are not fully exploiting the potential of these tools. So why is this, and what are the barriers, and how can we overcome them? And over the past 2 years, we have carried out a series of empirical studies, starting with a quantitative survey distributed across Europe. So we received 533 surveys, and the geographical distribution was from Austria, Belgium, France, Germany, Greece, Hungary, Italy, Spain, Slovakia, and Switzerland, which extends very much to the consortium where the consortium members are located and beyond. And the highlights of this survey was that we presented tools or tool types which are mainly relevant at the farm level and for sustainable production systems, such as agroecology or organic farming systems. And it was found that financial reasons, but also poor user experience in terms of complexity, are barriers to uptakes. And also, which is now confirmed of two of the presentations before me, that farmers also lack knowledge about existing technologies. And based on the tool classifications presented to our participants in this survey, they mainly agreed on the drivers rather than barriers. Peer-to-peer support in networks as well as government support are seen as most helpful for adoption. And although this was a result of a large survey, the respondents referred to types of tools, which is really important when I come to further results in the few seconds, and not specific tools. So we did not take into account farmers' experience with these existing tools or their individual farming situation. However, tools do fulfill a certain purpose, and their performance and experience of use are very much linked to the context of use. And therefore, Path2Dea worked very closely with its 6 showcases, which all are representations of typical farming systems, either in transition towards agroecology or already practicing agroecology in their everyday farming life. And here we go into detail. So I want to give you more insights into what are the drivers of enablers of digital tools from a farmer's perspective and based on the tools that they already use on their farm. So these are the results of our showcase workshops. The most important factors were those that increase profitability through technology, which also confirms basically the last results of the last presentation, and tools that help farmers keep track of their business and visualize results, were the most agreed on features across all showcases. And then what was also very important is that tools for collaboration and communication are essential because they allow for peer-to-peer exchange and also validation amongst peers. And these results relate to the principles of agroecology 2, 7, and 8, which is very important to understand what we can achieve in terms of contribution to agroecology. The next category, which is very nicely here in the results that we have, like these blocks that make digital tools suitable for agroecological farming, was agreed on by half of the showcases and relates to resource efficiency, ranging from production inputs to the amount of labor invested in production, but also social aspects, such as the improvement of working conditions and, as I said again, peer validation. And these aspects are related to the agroecological principles 7, 8, and 10. The third category is that makes a digital tool suitable for agroecological farming was agreed on. Were characteristics that very much relate to economic aspects, which is, for example, the marketing of their own products, but it really describes what is important to farmers in terms of the return on investment on tools. So the longer they last, the more reliable they are, the better the return on the initial investment they will take when they take up the digital tools for their farming system. But also the combination of a simplicity of the tool, so which provides them with a good user experience, and they need very little training, and tools are easy to use, is an enabler for the uptake of digital tools. And this in total relates to the principles 7, 11, and 13. And finally, the least important aspects, which is maybe a surprise because are the aspects such as interoperability and the reputation of the vendor. This is because interoperability is seen as one of the key enablers in smart agriculture. So a lot of the community about improving technology, producing technology, produces a lot of concepts and new technology that enables interoperability. However, for our showcases, this was not given a high priority. But I will explain later what the reason for that is. Further, we also need to understand what are the barriers and how can we overcome them. The barriers are shared by the showcases, were more consistent and mostly related to the fact that the tools were not currently suitable for the agroecological farming context. They were simply not good enough to outperform farmers' experience and sufficiently support their decision-making. And this, together with a lack of infrastructure, makes it difficult to use these tools that rely that rely on the frameworks such as good energy infrastructure, internet access, but also they had a lot of data security concerns. And these are now the first impressions of our workshop results. And to better understand these results, it is also necessary to look in the overall farming and framing conditions behind those data to better understand what are we actually talking about. So our showcases are distributed across Europe, and they cover from agroforestry to permanent crops such as vineyards and olive plots, to mixed cropping or mixed systems such as crop and livestock systems. But we also have beef cattle farming in Hungary, and we have under glass or greenhouse production in Spain. So when we look into that, we mainly cover or are very representative of the European farming system. And what is also important to understand that our showcases are very successful and well established, most of them in cooperatives, and they consist of many small farms working together, and they try to achieve a more sustainable production system that goes beyond efficiency. Standardization is very difficult as they're often small. Individual farms are too small for large equipment or require site-specific decision-making, for example, because of the landscape. And at this point, farmers collect and analyze their own data to better understand the results and organize their farming. So our showcases do certainly use a certain set of tools, but it was found to be a jigsaw puzzle of individual functionalities combined with the help of manual integration of relevant data into the tools, and often with the help of advisors from the cooperative. So while this may seem as a challenge, it is actually also an opportunity for a coordinated European approach to agroecology. And before I tell you why, let me give you some insights into the tools used by our showcases. Here we have the Hungarian showcase with the livestock farming and they use a combination of tools that help them to monitor their livestock, but also to understand better to understand weather. And they are also using renewable energy such as solar panels. And in terms of communication, they do use these tools to do education, contact building, but also promotion, and maybe to exchange important information with each other. The next showcase is our Italian showcase. They focus on olive production, as I said. And here we have a combination of tools that is very interesting, especially the so-called Poderi app. It was actually produced with the help of the cooperative. And this Poderi app is a decision support system that collects data from the farmers of the olive plots and analyzes them with the help of advisors and feeds them back with decision support depending on different decisions to be made across during the year, which is very interesting because this is a way of collecting also best practices in a very complex system that also tries to be sustainable in terms of understanding how to reduce pesticide input, and to foster biodiversity by keeping, as you can see here, the slopes green. So this is a very interesting approach in terms of co-creating tools that do not exist on the market, but that are very specific to this type of production system and for our showcase. But they still use, which is not a bad thing, they use Excel for managing orders, for example, and do calculations simply because it's not available or maybe also too expensive for them to buy any other systems. And then we have the Covidis showcase, which is actually a showcase that produces wine. And here we have also a combination. Here we have the first time also tractors included that help to manage the soil. And they are very much focusing also on water use efficiency because of irrigation systems, and they use renewable energies. They have certain decision support system and use also satellite images and drones. But it's still what we get as a feedback on throughout all these showcases is that data collection and analysis is still a challenge, and because of the data formats, but also how they can collect data and how they can feed them into the system, and which is often either manually done or the formats will not fit to the system they analyze the data with. So this is really data collection is a big challenge here. Then we go to the InAgro showcase, which is actually a showcase that is not really a showcase in terms of managed by a cooperative, but it's managed by it's a research facility that tries to understand how to include digital tools in agroforestry systems for the future, and they are using more advanced tools. And also invite a lot of farmers, which is quite important, to educate them about which tools can be used for what. And they also try to establish a good database in terms of understanding how to use these tools, how to establish these tools. So it's more like let's say a lighthouse that you can visit, and where you can get you educated if you want to invest in agroforestry in the future. And finally, we have Coexval, which is using or which produces, for example, tomatoes in glass houses. And here we see specialized tools and technologies that are suitable to manage these protected environments, and which is very different to open air agriculture. This has also to be noted when designing new tools, and because they are much more protected and can be much more easily controlled or connected to a single system that organizes all the different sensors, for example. And here we see also quite good use of tools already. And also in combination with renewable energy, which is also very important and gives a certain aspect to the resilience. But here still we have some challenges or reports from the showcases that they say if they want to take up new tools, these tools always have to be customized for their specific circumstances. So that means the tools come with a baseline, but to fully function in their environment, for them it takes a while to understand how to calibrate them for their specific situation, especially because they are working not with pesticides. They try to work with beneficial insects to support low impact farming. So all of these are often not things considered in the tools that are on the market. And here we have Terena in France. It's a mixed system with livestock and crops. And this is the showcase that uses, I would say, most variety of tools. Also because of the livestock production, which is very much developed already in terms of available tools on the market, whereas for olive production, for example, there is less tools available on the market. So here we have a good uptake of tools already, and already got also good insights how these tools can work together. Well, at the end of the day, we try to understand and try to help you also understand how can we overcome these barriers and use the insights we got in terms of enablers to design and develop digital tools in the future. And you need to understand that digital tools consist of so-called functional requirements and non-functional requirements. So the functional requirements define what the systems should do in relation to a specific farming activity, which is, for example, irrigation, fertilization, pest control, or herd management. So these tools are designed to measure, monitor, or control. And the non-functional requirements, they define how the system should perform. For example, it should be easy to use, easy to maintain, provide a good user experience, and be scalable. And the functional requirements focus on features and functionalities, which we, at least for now, try to categorize with and connect with the principles 1, 2, 3, 4, 5, 6, and 7. And they refer to improve resource efficiency and strengthen resilience on the farm. Non-functional requirements focus on quality attributes, which are very much related to social equity and responsibility and securities aspects. And these can be summarized under the principles 8, 9, 10, 11, 12, and 13. So the focus on features and functionalities means that we need to adapt these systems to specific production systems, for example, by using EU networks and use frameworks such as the European Network of Agroecology Living Labs to standardize metrics and share best practices. So, because the thing is that agroecological farming systems often are very complex and difficult to understand, and sometimes, and this is why farmers sometimes perceive that their individual decision making without digital tools outperforms their decision making with digital tools. And this is because we have no standardized metrics or best practices in terms of agroecology that can be translated into if-then rules that can be used to calibrate technologies. And therefore, we also found that and confirmed that by literature, it should be quite useful to use these agroecology living labs to especially standardize metrics and share best practices that can then be translated into the digital environment and to calibrate these tools so that they will really provide a good use to farmers in the future. On the side of the non-functional requirement, we have the focus on quality attributes. And here it's most important to co-create these tools with the farmers, as it is, for example, the case with the Poderi app. And we also need to understand in which cases we need to split tools into robust operational units and the complex background expert systems. So if you have tools that are used in a very challenging environment with a lot of mud and rain, and where you collect maybe only 2 parameters that are essential and analyze them in a complex background system, we have that seen already in one tool that is, for example, managed with a lot of databases that are coordinated with universities, then farmers can still get a very good decision support while they only collect the very, very limited amount of data on the field with operational units that are not sensitive to any environmental impacts. But also we need to understand how to improve the maintainability, because if you operate these tools far away from any technician or any support structure, then farmers should be able to maintain them easily. And last, it's for us, interoperability follows suitability, because it's not helpful if these systems are designed for large farming and do have a very easy interoperability, but if they're not suitable for these farming systems, then it's also not very helpful. So first, the suitability, which can be done, for example, through the agroecology living lab net, and then the interoperability. And last, it would be very helpful to establish a better collaboration with the statistical services of the EU to establish an open repository for agroecological data for calibrating these tools. We further did a study where we also asked tool designers what are their challenges and how can we overcome barriers for them. And it was very interesting that startups told us that when they try to present their solutions to farmers, sometimes they do not really trust these small startup companies and rather pay confidence in the big tool providers. So I don't have the best recommendation yet, but it should be there should be more opportunities for innovative companies and especially startups to test their solutions in early stages to really match them with the needs of the agroecological farming community. Yeah, so this is actually what we found. And now I don't have a survey, but I was wondering, when introducing new technologies and tools to agricultural users, what challenges do you face? That would be very interesting, and I would be very much interested to receive answers in the chat. Thank you so much.
Okay, Evelyn, thank you. So there is a challenge to the audience. Can you put the last slide back on for a couple of seconds, please? Because I'm sure half of the audience forgot what the question was.
Of course.
Just as a reminder. Yes. So the question is, answers in the chat, please. 3-word question. When introducing new technologies or tools to agriculture users, what challenges do you face? I guess we all have experience of this in some shape or form, so this is your opportunity to chip in. Okay, you have the answers trickling in, Evelyn. Hopefully it's useful.
Yes. All right. Thank you so much.
Okay, thank you. We'll leave the chat open, so just continue typing as you go. I would like to thank all the speakers for their excellent contributions. So I have taken plenty of notes here on the side to come back to later. So thank you very much for that. What we'll have now is an open question and answer session. Evelyn has nicely kick-started it with her open question on the challenges about introduction of technology. And what we have now is a second question going in a similar direction. This one has been pre-prepared by the organizers for us. So this is, you type it into the chat window that you can see on the screen there. So in your opinion, what is a good example of agroecologically appropriate technology? So something you have encountered or seen or heard of, and you think this is a good technology that fits into and supports our shift to agroecology. What is it? Again, this is a 3-word question, so just type in your response there. Okay, so I'll leave it open for some time so that you get a chance to type in your answers. Okay, sorry for the silence. I was just giving you time to think and type in your answer. So do continue typing, don't worry. I was just having a look at the questions and answers here. There is a couple of questions there. I'll just looking at them in order of appearance. There are two for Evangelia. I don't know if Evangelia are still here. I can't see all the participants. Oh, there you go. There you are. There was a question. This is about the granularity of the surveys. Do you have the survey answers by gender? And the second question, which is just a fact-finding mission, is where is it possible to get a PDF of the findings?
Okay, hello again. So by gender, I think it was not investigated for the moment, but still, as I said, for the Joint Research Center, we're still waiting for the analysis. So so maybe there we'll find something per gender, still to wait for that. And then for the outcomes, first of all, as I said, the JRC study, these preliminary results were already presented during the Digital conference that was organized by DG AGRI under EU Agri-Food Days. So if you go there in the website, you can also find these slides. But in any case, please, look or wait for the report to be published before summer.
Okay,
So,
thank you. Now we know how long do we have to wait. Okay,
but of course,
moving on to the next question. Yeah,
Martin, sorry. I mean, if there is also an intention to share the presentations, we can talk about it later. I would be happy to do so.
Yeah, okay. Yes, there was a question if it's possible to share the PDFs of the presentation. So if yes, do send it to us and we'll share it with the people that have registered. There is a question from Zelde. I guess this is to all the speakers. I will paraphrase slightly. So what the question is asking is, can technology replace agricultural extension? And if yes, how? Anybody would like to chip in? What are your thoughts on this, Evelyn?
Actually, from our showcases, I say that no, only to a certain extent. And actually, agricultural extension services are an enabler and should even be extended in the future in combination with digital tools, especially for agroecological farming systems that also consider very complex systemic influences and dynamics. So yes, no reduction.
Okay, thank you.
Maybe I could add something.
Yeah, of course.
To that. Yeah, thanks. So actually under the ReForest project, we've been doing interviews with agroforestry advisors about the extension situation around agroforestry. And one of the questions we've asked the advisors is about the use of digital tools. And it slightly surprised me that they were all really positive about digital tools and how useful they are. So I think often we focus on farmer use of digital tools, but actually they're really useful for advisors. And yeah, I'd agree with Evelyn that I don't think they replace extension services and advisors in most cases, but they can help them do a better job, I think.
Okay, thank you.
Just maybe one last remark. It's also important because when we get these responses about farmers are not aware of digital tools or new insights, then often these extension services are the link between, let's say, technology developers, science, and the farmers, and they are trustworthy persons. So that is really an enabling position here.
Okay, thank you. I had a question for Elias, actually. I was wondering, could you elaborate, because just first to check if I understood it right, one of your first slides, the robotic weeding, I think it was showing that the deployment of technology actually increases labor intensity. So did I get it right? And if yes, how does this work? Can you explain?
Yeah, so in that specific technology is, so basically what happens is that even though the seasonal labor, so sugar beet, for example, is still weeded in organic farming through manual labor. On the one hand, you get a significant reduction of that labor, but that translates into the farm operator managing the robot to increase the labor input by what we estimated is 5 times because of all the additional field operations that you need to manage, the baseline supervision, the transport from one field to the next, because the robot cannot go by itself according to regulation. And also all the intervention. For example, there is an incident, there is a problem, the robot gets
Yes.
stuck, and the person, the farm operator, has to intervene, travel to the field and resolve the incident. So overall, we got this data from an experimental farm in Bavaria, and the outcome has been, yes, you reduce manual weeding labor by 70%, but at the same time, you have a much higher labor input in terms of supervision tasks.
Okay.
Yeah.
That makes sense. So robots are not always labor saving, it seems. Or
Yeah,
at
it
least not
depends
yet.
on the technology, and
Yes.
also in this case, it's the specific technology. It's electric, so it doesn't have a lot of power. And what you need to have a much higher round of weeding. So for example, with a conventional equipment, you can weed the field three, 4 times, but with this robot, you can go up to 10, 15 times per season because you need to make sure the weeds stay small. Otherwise, they cannot be efficiently cut.
Okay, thank you.
Yeah.
I just saw the messages popping up as you were talking. We seem to have developed into a matchmaking service, which is great to see. So this is useful for some people. There is a question from Carolina to Evelyn. Could you elaborate a little more on how these tools are helping with marketing or sales?
Yeah, well, if these tools can connect, especially small-scale farmers, directly to consumers, then they can directly market these goods, or they can also introduce their produce into different, let's say, distributor networks. So there are two options: either directly used to sell, for example, to a restaurant or to a local supermarket or to a local vendor, or you introduce them to another distributor. So yeah, that's helpful, but it also is challenging because you have to manage these activities. And usually if you collaborate with within a cooperative, then the cooperative takes over these tasks for you, and you have to account for additional working hours in using these tools. So on the one hand, it gives you more power and maybe also more fair payment in terms of these aspects, but it also requires you to be more present in terms of constantly checking on the requests and feeding your output to the system. So, but what we discovered is in terms of also the food system connecting, if the farmers work with the cooperative and they just give the produce to the cooperative, they are disconnected from the food system. So they don't really know what's happening with their produce, and they receive a certain price that is negotiated by the cooperative. So the power is more out of their hands, while with using digital tools that help them directly to market to consumers, the power is more in the hands of the producer. But as I said before, you have to understand what comes with these opportunities as well. Yeah.
Okay, thank you. So I'm out of questions in the Q&A bit. Any other questions? Free flowing? Anybody wants to ask anything? Raise your hand. I should be able to see you. This is your opportunity to quiz the speakers. Okay, no. In which case, there is a question. Jolie, I hope I pronounced your name well.
Hi, no problem. It's just because there is somebody on the chat who would really like to answer the question of gender, which was my question, and cannot access, and that would be, I think, Zeude Ali Kebede wanted to answer. It's just they commented on the Q&A. So maybe if you can just allow them to open their microphone, then they can answer that question.
Okay. Francesca, can you do that?
Can this
I
person
don't think I
raise
can,
their-
as I'm not the owner.
Can this person raise their hand so that I can see who this person is? There's a lot of participants.
I think if you go to the Z at the end, I can just give you the contact.
It's done.
I can't find Zevi.
I found it, and the person can unmute and ask the question if needed.
Okay. Okay, unfortunately, can't fix the technology on the fly right now. So unless there are any more questions, don't go away. What we have is just a quick feedback session for you. So Francesca, if you could initiate the last bit of the interaction, please. Okay, so anyway, sorry, I was just reading the comment from Zeldi. Yes, the answer to you directly, Zeldi, if there is another session, we'll get in touch. We don't have the next session planned, but it may materialize in the near future. So if that happens, we'll do get in touch. Perhaps you could even become a speaker. Who knows? So anyway, to come back to the feedback session, you should be able to see the question on the screen. So how would you rate this event? Just give us an answer to that. The next one is, which bit did you find the most interesting? This is a three-word question, so type in whatever caught your interest. Okay, I'll just leave it a sec for you to finish typing. Okay, we have some positive comments in the chat. It's excellent and great interest to collaborate, which is good. This is why we do it. And Francesca, if she can do the last bit, which is anything you would want to change about this kind of seminar. Is there something we should do better? So the question, anything you would like to change, does not relate to the world, Trump, politics, anything like that, specific to this seminar, please, something we can actually do anything about. Okay, I can see the feedback appearing, which is great. So we have something to work with. I was trying to convince Francesca that we should do a third seminar in the series, but since she had to do all the legwork, maybe we can help her to arrange the next one. if it ever comes to being. Okay, so I guess at this point, the last thing for me to say is to thank all the speakers again. If we could give them a big hand, this was very informative for me. Like I said, I have plenty of notes and things to follow up on, so I hope you all enjoyed the event and found it useful. If we organize the third event in the series, we will be in touch, and thank you for attending.
Thank you.
Okay, so
Bye.
thank you and enjoy the rest of your day.